Hello students, welcome to Adantal. Good evening to all.
Good evening, sir.
Good evening, sir.
Good evening. So we will start from this question. Iit Jam 2015 MSQ. Polarization of the dielectric material is given, and then they are asking you about the volume charge density and the surface charge density. Bound, because dielectric will get polarized. And because of polarization, there is creation of bound charge within the volume and on the surface of the dielectric, and that is what we call as polarization. No, Arun, please check your options. Yes, Durga, very good. So this one is clearly wrong, because volume charge density is coming out.
Yes, sir.
And now we have to check B and C options first. Now for surfaces which are parallel to YZ plane, n cap will be plus minus I cap. So therefore sigma B will be P dot plus minus I cap. It means it will be 3 I cap plus 4j cap dot with plus minus I cap. So it will be plus minus 3. So mod will be 3. So that is correct. And for surfaces parallel to XZ plane, n cap will be plus minus j cap. So therefore sigma B in this case will be P dot plus minus j cap, that is 3 I cap plus 4j cap dot with. So it will be plus minus 4. So in this case magnitude will be 4. So this one is also correct. And clearly this one is wrong, because the magnitude, net magnitude is 0. Net charge is 0.
Yes. Okay.
And it always happens. The amount of charge on the surface, it is numerically equal to the amount of charge present within the volume. And they also have opposite nature. That is also true.
Yes, sir.
We will see some of the questions later on. So is it clear to everyone? This is a good question, okay? Because it
Yes, sir.
makes use of both the formulae and direction of the normal vector also. Okay, so conceptual one. Second. Again based on polarization. Durga partially correct. Rita again, it's not correct completely. At least you people should be sure about A and B. Bound volume charge density and bound surface charge density. So it is constant, so bound volume charge density is 0. So this is correct. No, Durga, again partially correct. And what about surface charge density?
That's also 0.
How?
n cap can be written as r cap, और फिर r cap को हम कार्टेशियन में लिख सकते हैं, like xi cap plus yj cap plus zk cap under root x square plus y square plus z square.
बट वो स्फेरिकल है ना, यू नीड टू यूज स्फेरिकल को जब कार्टेशियन में लिखते हो वो कैसे होता है, वो दिखना है ना आपको। याद है कुछ?
हाँ सर, अब याद।
Like this. So it will be p naught sin theta cos phi. No, it is not 0. This. And now because phi varies from 0 to 2 pi, so it will also vary. So for phi ranging from 0 to pi, at pi by 2 it will be 0, and from pi by 2 to pi it will be negative. So it means the surface charge density, it will change its sign as phi changes. Okay.
Yes.
So now at this point, what is the value of theta? You remember, this theta angle is with z axis. Sorry. Like this. This is r cos theta. Remember?
Yes, sir.
This was phi. So theta is 0 na? When the point is lying on z axis, for that theta is 0. So if theta is 0, then sigma b will be 0. Am I right? So B option is also correct, na?
Yes, sir.
And what about the electric field inside the dielectric? Obviously that is non-zero, na?
No, that's not zero.
How?
सर ये जो सिग्मा भी है वो तो वेरी कर रहा है.
हाँ, बिल्कुल. Otherwise also dielectric में there is polarization, ना? तो polarization की वजह से we have seen in our 12th class that there is an electric field inside the capacitor, na?
Yes, sir.
So that is a dielectric. तो dielectric में electric field तो हो गई. So
Yes.
when phi varies from 0 to 2 pi, it changes its sign, na? So it means there is a positive charge here, negative charge here, na? Please check. Depending upon phi. So direction of polarization is towards this, and hence electric field is towards this. So electric field is non-zero clearly. So it means this option is wrong. The sign of the surface charge density changes over the surface. That is also
Yes,
correct.
that's right.
So ABDR, correct? Please check everyone. Clear?
Yes, sir.
No need to make that diagram even. It is clear from this part also that when phi changes, cos phi will change its sign. Okay. For some of the angles it will be positive, and for others it will be negative. So it means it changes its sign. Very good, Rupa. Yes, Rita, very good. Because electric field is due to a dipole, na? So it will vary as 1 by r cube. So this one is clearly wrong. Bound charge density, surface charge density is P naught cos theta. Now C option, electric potential due to a dipole. What is the formula?
1/4 pi epsilon naught P dot r cube upon r square. P यहाँ वो dipole moment है.
P dot z by r square. This one.
Yes, sir.
P naught r12 epsilon naught. Same is given. Electric field outside is equivalent to that of dipole at origin. What about this? Now again, if we try to make the diagram,
Dipole बन रहा है.
yes, try to make the diagram, then what will happen?
Cos theta will be होगा.
Yes, cos theta. That's cos theta. So negative charge will be downward and positive will be upward. Na? Because
Yes, sir.
it will be positive for a theta ranging from minus pi by 2 to pi by 2, and from for other angles it will be negative, positive, na? Negative, sorry. Okay. So clearly it is dipole at the origin.
सर ये इस स्टेप में डाइपोल मोमेंट हमने निकाला वो दोस्तों 4/3 pi r cube और into p ये वाला स्टेप.
Polarization का फार्मूला dipole moment pi unit volume होता है.
यस सर. हाँ ओके.
Moment is volume into polarization.
Okay.
4/3 pi r cube.
जी सर.
सर स्मॉल r की जगह कैपिटल क्यू r आएगा ना.
हाँ वो आप कर सकते हैं, वो मैंने ध्यान नहीं दिया, वो तो ऑब्वियसली. ओके.
Yes, sir.
नेक्स्ट वन. वेरी गुड. No, Ritika. See, it is A option. Figure 1 and figure 2. Charging and discharging. Okay, let me tell you about this. See, during charging, the charge on the capacitor is given by. So current will be this. Okay.
Yes, sir.
During the charging. This is the charge. This is the current. Na? Charge is increasing and current is decreasing. You can see it is exponentially decaying. It is increasing na? Because this is decaying. 1 minus something decreasing. It will increase. Please check.
Yes, sir.
Clear to everyone?
Yes, sir.
Iit Jam 2020. Again, surface, volume, charge and space. So lots of questions are there based on polarization, you can see. Yes, Durga. No, Arun. Yes. Now, let me tell you something. See, polarization is pointing in the direction of r cap. Na? What does it mean?
It means actually it's negative.
Inner surface, inner part will be negative and outer part will be positive. Okay. Because polarization points from negative to positive charge. Isn't it?
Yes, sir.
It means while finding the surface bound charge, you need to take care of this fact. Therefore, bound charge density at inner radius, it will be given by negative sign like this, and bound charge density at outer surface will be given by positive sign like this. Is it clear to all? Because we have concluded that there will be negative and positive charges. So this one is wrong, this one is wrong, this one is correct, na? And let us check about volume bound charge density. Because
0 हो जाएगा.
yes,
It's constant. So
रेडियल वेक्टर है ना, उसका डॉट प्रोडक्ट 0 होता है. इस चीज का डॉट प्रोडक्ट एक्चुअली 0 होता है. ये भी रॉन्ग है, तो ये तो ठीक है. Okay, so only C is correct. Although it was MSQ, but only C is correct. Others are wrong. Clear?
yes, sir.
Yes.
A 10 picofarad capacitor is charged to 50 volt. Then battery is removed, and then again second uncharged capacitor is connected to the first one in parallel, and the final voltage across the second capacitor is given, so its capacitance would be. It means same will be the voltage across the first capacitor after connecting them in parallel, because in parallel voltage will be same. Na? Yes, sir. No, Durga. When C2 is connected in parallel to C1, both will have same potential. Okay. Now, total charge will be same. This is 500 picocoulomb. This will be C1 into 20 plus C2 into 20. So 500 picocoulomb equal to C1 plus C2 into 20. So C1 plus C2 is 500 picocoulomb by 20, 0, 25 picofarad. C1 is 10 picofarad. So C2 will be 15. Here is the answer. Please check everyone. Is it clear? Please tell.
Yes, sir.
Yes, sir.
Simple funda that voltage in parallel is same and charges are different. Now based on magnetostatics. Yes, Durga, Rita. Let me help you in making the diagram for this particular question. So one wire is located at z equal to minus a in the xz plane. Okay. Here is the wire at the point 0, 0, minus a. This, and the another wire is at z equal to plus a in the yz plane, like this. Means the point is 0, 0, a. And there is a magnetic dipole at the origin. In both the wires, current is same. So we need to find the angle made by the magnetic. Okay. So now it means we need to find the resultant magnetic field at point O. So magnetic needle will point out in the direction of the resultant magnetic field. So we need to find the direction of resultant magnetic field due to both the wires. Okay. Now, magnetic field at O due to L1. Yes, sir. Let's call this field as B1. This is the direction and sign, because point O is lying above the wire. No? If you hold the wire in your right hand with the thumb pointing in the direction of current and the fingers, they are in this direction. See my hand. They are in the direction opposite to that of Y. It means minus J cap. Okay. And the magnetic field at O due to L2. Mu naught I by 2 pi I. See, it is going in my fingers. Okay. Now, both B1 and B2 are of same magnitude. So resultant will be equally inclined between them. So one is pointing in negative X direction and other is in negative Y direction, like this. It means one is towards this, other is towards this. So resultant will be midway, like this, making an angle 45 with this. Okay. And this is in fact 180. So total angle with the positive X axis will be 225. Please check. Is it clear?
Yes, sir.
What is the total angle? 225. Na?
Yes, sir. With
Yes,
the
sir.
x-axis.
With respect to positive X axis, we need to find. Na? Is it clear?
Yes, sir.
So try to solve this one.
Please unmute, sir.
All the students are not answering, only 3, 4 students every time. No, Durga. Yes, Wakadir. Rita, yours is also correct. Arun, yours is wrong. Magnetic permeability of vacuum. Yes, Ritika. See, force is Q V cross B. Na? So F is Q V B sin theta. So B is F by Q V. So dimensions of B are dimensions of F by dimensions of Q and V. So now B dot dl is mu naught I na, according to Ampere circuit law. So dimensions of mu naught will be dimensions of B, dimensions of L, dimensions of I na. So A option is correct. Please check. And if you remember these dimensions directly, then you can save your time. And you can get the answer from here also. C square is 1 by mu naught epsilon naught. So mu naught is 1 by epsilon naught C square. From here also you can do. Okay.
Yes, sir.
Another one of similar kind. Yes, Rita. Here is the answer. No need to solve anything. I have solved it already.
Yes, sir.
Okay.
Yes, sir.
This one. Yes, Arun. So this is the generalized formula. So now you can put the values for this particular question. N is 6. Okay. So in our case, N is 6. Root 3 mu naught I by pi r. Na? Please check everyone.
Yes, sir.
So I have given you the generalized formula, which is dependent only on the number of sides. And there is another formula which is in terms of side length, in which this side length is given, this distance is not given. Okay. So be careful while using the formula. Yes, sir. So you will make use of Ampere circuit law. In a loop C1, current is I1 and I2. Na? So B dot dl is mu naught I. It means it will be I1 plus I2 into mu naught. Isn't it? And it is given to be 2. Na? 2 mu naught. I1 plus I2 equal to 2. Please check.
Yes, sir.
Now for C2, it is I2 plus I3. Na? C3, all of them. Only mu naught. So 3 minus 1 will give me I3. Minus 1 means into the paper. Negative means in. 3 minus 2 will give me I1. Minus 3 into the paper. I1 is 3 ampere into the paper. I3 is 1 ampere into the paper. Wrong, na? This one is also wrong. Let us check I2.
Yes, sir.
So it means from 1. Minus 3 plus I2 is 2. So I2 will be 5. So out of the paper.
Yes, sir.
So B is also correct. Please check. Here. So again, very different question and interesting one. We cannot even imagine that ampere circuital law can also be used in this manner. This one. Yes, Durga, very good. Yes, Arun. Yes, Rita. See, V dot B, it is coming out to be non-zero. It means V is not parallel to B, not perpendicular to B. And V cross B is also not zero. It means V is not parallel to B. It means it is making some angle between 0 and 90 degree. So therefore, trajectory of the particle will be helical. Because for 0 it will be straight line, for 90 degree it will be circle. So it is not a circle. Now what to do in order to get the time? Above the xy plane.
Let's pitch of helix.
So that is V z t. Distance traveled along that axis will be the velocity along that axis into time taken.
Yes, sir.
Given
And
to
V
and
just
velocity
equal
in
to
that direction is 2. So time will be 2 by 2, that is 1 second. A option. Please check.
Yes, sir.
Yes, Rita. Yes, Durga. Yes, Arun. What Kajal is wrong? See. It is wound like this. Then another one. So 1.5 turn is there. Okay. So now there are 3 things. One due to this straight portion, another due to this disc loop around the disc, and third due to this straight portion. Okay. I by R आएगा. See the direction. Magnetic field at O due to straight portion DE. This one. And magnetic field at O due to circular portion. Let me name them A, B, C, D, E. So it is BCD, then BCD. BCD, then again BCD. Na? BCDG like this. BCDG, then again BCD. Na? Okay, so it makes 3.5 turn. 1.5 turn, sorry.
Yes, sir.
So mu naught by 4 pi. 1.5 means total angle will be 3 pi. Na? 2 pi for one complete circle and pi for another half. So this will be the total magnetic field. And all of them, they are pointing in the same direction. Na? So total magnetic field at O. This one is the answer. Please check. Here.
Yes, sir.
Yes, Arun, Rita, very good. Durga. Yes, Akash. Yes, Vakajal. Now it is in terms of side. So in terms of side length, A we have so here n is equal to 3 for equilateral triangle. Therefore,
सर only root 3 आएगा tan की बस.
please check. So these are the two shortcut formulas. This is in terms of distance from the center to vertex. This is in terms of side length. Okay. If you can remember both the formulas, then you can get the answer very easily just in one step during the exam.
Yes, sir.
Lots of questions are there from electricity magnetism. Tomorrow also we will continue with electricity magnetism. Still some part is pending. Electromagnetic waves and all. Very good, Durga. Yes, Rita. Yes, Arun. See now. It is given that in the question, particle moves undeflected. Okay, in the presence of electric and magnetic field, it means sum total of electric and magnetic forces is 0. means the net force from the particle is 0, I mean to say. So if I take Q common, it means E plus V cross B is 0. So E is minus V cross B, that is B cross V, and electric field is along minus Z direction. Magnetic field is along, let me put the values. So J cross I will give me minus K, so velocity is along positive X direction, isn't it?
Yes, sir.
Yes, sir.
And it is independent of nature of charge, it doesn't depend upon Q. Independent of the nature of charge.
Yes, sir.
So I'm not going to solve this question, I will just tell you the answer, whether you are correct or not. So try this one. How to check? Can anyone tell me?
तो del dot
B
b
equal
0
to
हो जाना चाहिए.
So the one which does not give del dot B equal to 0 is an impossible magnetic field. So you need to check the divergence of all of the options. Very good. Arun. Very good. Aksh, Rita, Durga is from impossible, not a possible one. It's B option. All others they give del dot B as 0.
Yes, sir.
It does not give 0. Very good, Arun, very quick. Very good, Durga. Rita, it's only 2, not 2Z.
Yes, sir. Yes, sir. Sorry, sir.
See here, I can tell you from the diagram itself only. See, surface current is given. Okay. So whenever surface current is there, tangential component is discontinuous. But they are asking you only about the normal component. So it is there to confuse you people. Okay. So this has nothing to do with the question, because they are not asking us about the tangential one, they are asking about the normal one. And we know that V normal 1 is equal to V normal 2 always, isn't it?
Yes, sir.
This is always true. And because the interface is Z axis and the normal to interface is Z component, and we are saying that the normal component is equal, so it means below the interface, again the normal component will be 2 millitesla, isn't it? Please check.
Yes, sir.
Yes, sir.
Very good, Durga. Again, interface is Z equal to 0 plane. So normal to the interface will be along Z. And interface again carries surface current. So tangential component will be discontinuous. So what was the formula? B tangent 1 minus B tangent to cross N1 to cap. It is equal to surface current K vector, mu not K vector, sorry. because I'm writing this equation for B, not for H. Na?
Yes, sir.
Yes,
P
sir.
1 means 3I cap plus 5K cap minus I cap 3J cap 5K cap cross N12 means K cap. Na? Because when we move from medium 1 to 2, we are moving in the direction of Z axis. Na? So when I take the cross product 3, I cross K cross K will give me 0. First
Sir?
let us solve this one. Yes.
सर जो बी टेंजेंशियल कंपोनेंट है उसमें के तो हटा सकते हैं ना अपन बी टेंजेंशियल इक्वल टू 3i के
वो अपने आप ही हट जाएगा, अपने आप ही कंट्रीब्यूट नहीं करेगा.
यस सर
यहाँ पे तो कैंसिल हो रहा है, बट अदरवाइज इफ देयर इज सम कंपोनेंट देन K cross K will be 0. So you can directly use this one in diagram. No need to see that we need to remove this K component or it is automatically built up. This magnitude, I need to take the magnitude also. No? I'm sorry.
Yes, sir.
Because on the right hand side, I am taking the magnitude. This one is right now. So it will be minus 3 square. So it's not 5, root 13. No?
यस सर रूट 13
So please check this one. Are you getting 2.87?
Yes, sir.
This one. Let me give you the hint. This one is based on electromagnetic induction. Yes, Rita. Yes, Durga. And one more thing, this is a question of varying magnetic field, because the magnetic field acting on this, it is only due to this wire, and it depends upon the distance of the point from the wire. No? Magnetic
Yes,
field
sir.
of this kind, mu naught I
2 pi by x
2 by x, no? And x varies from R to R plus W.
plus w. Yes, sir. So we have calculate the change in flux.
Yes, so you need to integrate it actually. So the magnetic flux through the loop is, yes, Vakajal, 5B. B means magnetic flux, okay? So it is R to R plus W, B dot ds, because flux is surface integral of the dot product with area vector. This is B, and ds will be LDX, because this is fixed, only this one is varying. Okay?
यस सर
So mu naught IL by 2 pi, so dx by x. This, so induced EMF minus p phi by dt minus mu naught IL by 2 pi R by R plus W, d by dt of R plus W by R. Because I can write it as 1 plus W by R. Na? dr by dt can be written as V. So therefore current, it is E by R. So this is option C, you can check. Okay. Clear?
Yes, sir.
So that's all for today, students. So tomorrow we will continue with the electricity and magnetism part 3. Okay, students, bye bye, take care.
ओके सर थैंक यू